Hi everyone, so I'm sorry I can't be there today, but we're going to go over Unit 10, Lesson 3 together with this video. So if you could pause here and try the do now and come back to it, I'll explain how it goes in just a moment. So identifying the slope and intercept of every equation, we would compare it to y equals mx plus b form, where m is representing the slope and b is representing the y-intercept. So the number in front of x is the slope. The number attached to the x value with either addition or subtraction is the y-intercept, b. So if we do that here, what we figure out is that we have a slope of 7, which can be written as 7 over 1, and we have a y-intercept, or a b, of 10. If we do that for the next question, we have a slope of negative 5/7, and we have a y-intercept of 4. And if we go over here, if you tried following and trying to identify a slope by the number in front of x, that only works if y is on the left side of the equation and our other values are on the right. And so because this isn't written in that format, well, how are we supposed to do that? Well, that's what we're going to talk about today. We're going to rewrite things so that they are now in slope-intercept form. Okay, and remember, slope-intercept form, what I mean by that is y equals mx plus b. So I've taken the do now question that we were looking at and I've copied it down here for our notes today. What we need to do is to get the equation with y by itself. So the only way to get y completely by itself would be to remove the 3x by subtracting it, doing its inverse to both sides. So I have to do that over on the other side as well. Now the 8 and the negative 3x are not like terms, so while they do cancel out on the left side, on the right side, they don't cancel out, but they can't be put together. So I would keep them as two separate pieces, the negative 3x and the positive 8, which now looks like plus 8. Now it is in a form where we can identify the slope as negative 3 and the y-intercept as 8. Now, that was a fairly straightforward one. There was only one step to completing that. They can get a little bit more complex, so I tried to give you a more complex one to look at here, and it's going to follow a whole bunch of steps. These steps should seem familiar to you because they were the same steps we did when we were trying to solve equations of one variable. The small little twist here is now we have a y as well, so we have to work on getting y by itself. Now, you might remember I just said up here that we like having y on the left side, but actually, we just really care that y is by itself. So if y ends up alone on the right side, that's okay too. So we go down here. Let's follow these steps and see what we can do. So we're going to distribute if necessary, and that is the case here. So I'm going to go ahead and distribute the 4 to give 4x plus 16, and then copy the rest of that side. On the right, I also have a distributive property that has to happen. So that'll become 2x minus 4y. And so we have completed the distributive property. We combine like terms if we can. So we're going to go ahead and take our 16 and our 2 on the left side and put them together. So that's 4x plus 14 equals 2x minus 4y. So the next step, just if you want to keep organized, is highly suggested. Step 3, move the y terms to the left. Okay, so that's what I was mentioning before up here when I wrote y equals mx plus b form. We usually have y on the left. It's okay if it's alone on the right, but let's just stick with tradition here. So I'm going to go ahead and I'm going to move the 4y over to the left side by doing the opposite of what it was on the right side, so it can go away. However, the 4y, the 4x, and the 14 are not like terms, so they're kind of just stuck written that way. So we have 4y plus 4x plus 14 equals a lonely 2x on the other side. So we've distributed, we've combined like terms, we've moved the y terms to the left. We're going to move everything else, the x and the constant numbers, over to the other side, to the right. So the opposite of plus 4x would be minus 4x. That actually does have a like term on this side, so we'll have to put those together. And the opposite of plus 14 will be minus 14. That's not a like term. That'll stay by itself. So The two terms that we wanted to move cancel out on the left side. We're left with 4y. And then 2x minus 4x is negative 2x. And we have minus 14 all by itself. Okay, we almost have y alone. Okay, step 5, you can see here, says if the y term has a coefficient other than 1. It does, it's 4 here. Okay, we have to divide to get y completely by itself. So both sides, entire sides, get divided by 4. So the 4's cancel out, leaving y equals negative 2 over 4, or negative 1/2 in front of the x, and then negative 14 over 4, or negative 7/2 if you reduce that down to simplest terms over here. So now we have a slope of negative 1/2 and a y-intercept of negative 7/2, or negative 3.5 there for us to identify if we needed to. So even though it started off as looking something a little bit complex, we have it down now to something in slope-intercept form. I know they're both fractions, but it's actually in a simplified form now. There is a small note down here. Okay, if the x's or the y's go away, that's okay. It might be in one of these two forms, which we have previously discussed. Those are horizontal and vertical lines, so that might happen to you. Now, I'm not going to do every single question like we don't normally do in class anyway. I have a couple of examples that I'm going to pick and choose from to do with you. All right, and then we're also going to move on to different types of exercises where not only do you have to rearrange things, but you also have to graph them once you have the slope and intercept. So let's just do maybe the odds on this sheet. I think that will be fair. So let's look at number 1. I have 3x plus 7 equals y. Well, remember what I said before. If y is on the other side by itself, that's okay. All you have to do, if that is not to your liking because it's not literally in this form, is switch the sides completely. So the right side can become the left, and the left side can become the right. So this one is actually pretty straightforward. We can just switch the sides, and we now can identify that the slope is 3, or 3 over 1, and the y-intercept is 7. So there's our answer for that. Let's take a look at number 3. Okay, y is on the left side this time, but so is some other things. So we want to get the y on the left and everything else on the right. So the opposite of a 3x would be a negative 3x. So we will subtract that to both sides. That gets the y by itself. But on the other side, we have non-like terms. So the negative 3x and this negative 8 will now become negative 3x minus 8, and that's all we can do. The slope is negative 3, or negative 3 over 1, and the y-intercept is negative 8. There's what we needed. Now, if at any point you want to hear what I said about one of these problems again, don't hesitate to go back, rewind, and relook. All right, let's do 5 together. So we don't have any distributive property, and we don't have any like terms. So our jobs are to get the y's on the left side of the equal sign, and everything else on the right side. So the y's are where we need it, but we need to move the 8x over and the 10 over by adding both of them, because that's the opposite of what they were. So we're going to add them to the other side. That leaves us with just 3y on the left. And on the right, they're not like terms. It stays 8x plus 10. Y is on the correct side, but not by itself. We have to divide both sides by 3. And 3 does not go into either of those numbers, so it's going to simply end up being 8/3 x plus 10/3. Now that's in this section because I most likely wouldn't have you graph a y-intercept of 10/3. It's a little bit annoying to do that. So the slope being a fraction is fine. I might do it occasionally, but usually I won't have you write a fractional y-intercept graphically. All right, let's look at number 7. You'll notice there are no x's. That's okay. We still just follow our rules that says y on the left side, okay, and everything else on the right side. But we need the coefficient of y to be 1. So I will have to divide both sides by negative 3. That will get me y equals negative 5. So this is just a special one because this is going to end up being a horizontal line, which means we have 0 slope, and the y-intercept is negative 5. All right, lastly, we'll look at the most complex one on this page, which is question number 9. For this one, we will distribute the 2 to both terms, making 6x minus 2y. On the other side, there's no number in front of this parentheses with the addition, so it's technically just distributing a positive 1, which doesn't change anything. So that's just 8 plus 6x minus 2. So distributive property is done. We will now combine like terms. So what I'll have to do is add the 8 and the negative 2 together on the right-hand side, since they are both constant numbers. So the 6x was not a like term, but those become a positive 6. I need to get everything that's not a y to the other side, so I will have to subtract this 6x. And what you'll notice is even though this one started with an x, it's not going to have one anymore, because not only do the 6x's and negative 6x's cancel out on the left, they're also reducing each other out on the right. So we only have a negative 2y and a 6 left. So it's going to be very similar to the one that we just did over here at number 7, because if we divide both sides by negative 2, we get y equals negative 3. Another horizontal line which has no slope, and it has a y-intercept that we see just as our number, negative 3. So like I said, at this point, maybe you might want to rewind and go back to the beginning and relook at these, especially if you're trying to copy them down. Don't forget, I also will have my answer key posted in case you feel like that's a better option for you. So let's look at some that we're going to have to graph. Okay, so I think I'll stick with the theme and I'll do odds with you. Okay, so I am going to go to the next page, rewind if you need to look at those again, but let's jump into number 11 on this sheet. So I can't go and graph it immediately because it's not in y equals mx plus b form. So I will have to get rid of the x on the left-hand side by subtracting x from both sides. That now gives me y as the only type of term on the left. 4 and x are not like terms, so they stay separate. You're noticing that I'm writing the x first every time because it's y equals mx plus b form. I want the constant numbers later. So I know some of you might have written this as 4 minus x. We're not going to do that. We're going to write it the other way, negative x plus 4. Now, remember, there is a 1 in front of this x as well. So if you want to view that as negative 1x plus 4, that's great. That's going to be helpful for this next part because I have to divide both sides by 2. And now you can see negative 1 divided by 2 right here. That's going to end up being a fraction, negative 1/2 in front of the x. But when I do that over here with the 4, 4 divided by 2 is just 2. So now I have it in the form that we need. It helps me see that the slope is negative 1/2 and the y-intercept is 2. So on my graph, I'm going to start at a y value of 2 and do a change of y of negative 1 and a change of x of 2. That would be down 1, right 2. Down 1, right 2. As many times as I can fit because we like using all of the space on our paper, on our graph. You can also reverse that process to find some more points the other way. So instead of down 1, right 2, we can go up 1, left 2. And we find some more points for us to plot for our line, since this was a linear equation. So what I would be able to do now, I was ill-prepared and didn't have a straight edge on me, so I will use a drawer that I have. We will line this up, and we will now go ahead and graph our line. And so even though it was written as 2y plus x equals 4, I was able to take that pattern and write it on a graph as a linear equation, a linear graph. Okay, we'll wrap this up by looking at the last page and looking at 13, 15, and 17 on this page. So everything on the left. What we'll notice here is one of our special cases that we didn't get to talk about yet today, there are no y's. When we're in the situation where there is no y's, it's very special. You can't follow those rules from the front page at all, but you can still solve the equation. So we just solve for x. We divide both sides by 2, and we get x equals 2. And you are required to memorize that anytime you have an x equals equation, when you go to graph that, it is going to be a vertical line. It is a vertical line where x equals 2, because the x coordinate can just always be 2. So we go ahead and draw that vertical line in at x equals 2. Now, not a special case is number 15. If we go ahead and take a look at that, we will have to rearrange this a little bit. We need to get y by itself on the left side. So I need to subtract 3x from both sides. That leaves negative 2y as the only thing on the left. And unlike terms, negative 3x and positive 4 on the right. We will divide both sides by negative 2. So because 2 does not go into 3, the only thing we can do with this is know a negative divided by a negative is a positive, but we're going to keep that written as the fraction 3/2 in front of our x. But then the positive 4 divided by negative 2, that at least goes in evenly. 4 divided by negative 2 is negative 2. So we now know that our slope is positive 3/2, and our y-intercept is negative 2. So I'm going to start at the y-intercept of negative 2 and use a change in y and a change of x of 3 over 2. That's up 3, right 2. Up 3, right 2. Can't do it anymore, but maybe I can backtrack once. Instead of up 3, right 2, I'll go down 3, left 2 to fit one more point. And what I can do now is take a straight edge or your line tool if you're doing this digitally and connect them to form a line. All right, one more to go. So we have 2 parentheses, x plus 4 equals negative 2y. As I said before, if you don't like the fact that the y's are on the other side because we like them being on the left, go ahead and just flip-flop the entire sides around, and then go ahead and follow your rules. So we have the distributive property that can be used for this 2 on the right-hand side. So we have negative 2y equals 2x plus 8. The y's are on the left. Everything else is on the right. No like terms to combine. So we only just have to get the y by itself now. So we divide everything by negative 2. Y will equal 2 divided by negative 2, which is negative 1 in front of our x, and 8 divided by negative 2, which is negative 4. So we have a slope of negative 1, or negative 1 over 1 for a fraction, and a y-intercept of negative 4. So I start at negative 4, and I go down 1 over 1, and I would go down 1 over 1 more if I could, but I ran out of room already. So instead of going down 1, right 1, up 1, left 1 instead. So I'll backtrack and fill in some more points. And so this creates, get to a clean side here, creates our last line of the lesson. So you have a couple of options right now of what you can do since I'm not there. You had the homework you went over, and this video is going to end up being close to 20 minutes long, so you should still have plenty of time left in the period. Maybe you went back and rewound and read over some of these questions again, so that took up some time. That's great and fine if you did. If you haven't done that and want to do that now, go ahead. We also have the even questions. Now I've posted the answer key for you, so if you want to try some of the evens to see if you understand today's lesson, you can do that and check the key. And our last option is the homework should have posted online by now, so you also have that you have to look at. So I hope you all have a great day while I'm not there, and choose any of those options and take a look at some more of these questions. Thanks.